Hi everyone. Here's a picture from you can showing packs of meat from a supermarket. If you are facing this picture, and it's very hard to make a decision because you're just not sure where this meat is from, how it come here. And so, how about if you know a little bit more information about the origin of the meat? That's all about my talk. So uh, my work is relevant to the processing facility in this supply chain. So what's the problem and why it matters? The left picture, you can say we have year tags to track the animal from it was born up until it was sold to abattoir. On the right hand side, you can say after it comes out from the abattoir, it becomes a piece of meat. The tracking is lost. You don't know which pack is from which animal. Or if you're lucky, you may know this pack is from that batch of animals going to the abattoir. Because the red meat export market is quite competitive and high-end customers are willing to pay a high price for a product which share some information like its producer and how it arrives on your table. So um, the current method, DNA based, is accurate. However, people need to prepare samples, use specific equipment, and follow specific procedures. That's time delay and the time consuming, also cost money. It's just impossible to do this on spot. So you may wonder what happened in abattoir. Here's a very brief video showing the process of the meat processing from a carcass to pack of meat. Can you say the video is playing? Okay. So you can say primal cut from carcass, then being thrown out to the conveying belt, then the meat being trimmed, then being packed, then it's being transported to wholesalers and then retailers. That's how you say the packs of meat in supermarket. So can we automatically track individual from cuts of meat? So from the bottom left image, you can say carcass being hung with a hook. This meat hook is embedded with RFID tag. So when the hook traveling or reel passing a RFID radar shown on top left image, and the RFID number can be read automatically. So that's a unique number for that carcass. On the right hand side, you can say there's a label machine which can be used to print a product label. In the packaging area, individual piece of meat can be packed, then with that sticker, product label. So if we can connect the RFID number of carcass to the product label number, so that means we can track individual piece of meat from its origin animal. So that animal RFID corresponding to its year tag, so that we will know which piece of meat is from which farm, which animal. That's the idea. So what are the research questions and the challenge? The question is how to automatically track this, and what's the challenge, you may ask. So you can say from the bottom left image, they look very similar. The texture look very similar. Even sometimes the size, its size is similar. And in the middle picture, you can say the meat is flexible. Their shape can change, can be twisted, and sometimes they can even be stacked. So how to detect and track multiple 3D non-rigid deformable objects? And also there's occlusion. From right hand side image, you can say, the the meat can be occluded by heads of butchers, by even by other meats. So how to address this challenge? It's a quite challenging problem. So with our experiment, we collect multiple videos with different scenarios, and also we curate data for machine learning. So left picture showing, the meat we labeled, including those individual meat, and also the butcher's head. And we want to distinguish them when meat are occluded. Right-hand side image is simulated data, because even you record multiple videos, it's very hard to mimic meats being thrown from different angles, and from how they move in 3D space. So we designed this simulation software to mimic multiple meats traveling at different directions, different scenarios, to collect data, so that we can use those data together with the real data to train our model. So we built our initial version of machine learning model to predict what will be the current location of the meat based on information prior to the current time t, which means t plus 1, t minus 1, sorry. So we use the network to predict what will be the next status of the meat, where it will be using both RGB video together with the depth information of the meat, which is 3D. Here are two simple scenarios. Left-hand side, we demo video showing if those pieces of meat are not touching together. So you can say they can be correctly tracked, because it's simple to detect and track, and there's nothing confusing here. On the right-hand side video, you can say if they are touched, for example, if you throw a meat next to each other, so in this case, even they're touched, we can still correctly identify them and track them. So how about showing this in 3D with a cutoff niche touching? On left-hand side, you can say in 3D, those pieces of meat are being tracked, and even they're touching. So we use we split the meat, entire piece of meat, into multiple 3D elements, because as I mentioned, they are flexible, the shape can change. We use multiple 3D elements to mimic that meat, individual meat. On the right-hand side, showing with some sort of overlapping, stacking one meat, multiple pieces present. Different colors showing different pieces of meat. Because sometimes those pieces of meat can be moved out of the camera view. So because I mentioned this is a hard problem to solve, especially when meat are stacked, seriously stacked and overlapped. So here's our technology pathway to address the challenge. And so for the sensing, we want to use we are currently using high resolution 3D imaging sensor. So you can get information of the shape, also about the thickness of individual piece of meat and the location in 3D space. So for algorithms, we have developed some initial version of the algorithm, but we're still working on this using both computer vision and the artificial intelligence method to address the challenge. So if we get a good result for this, overlapping and stacking situation, then we would like to develop industry demonstrator, then engage with industry. Is our technology pathway. So in summary, I talk about the 3D imaging-based object detection and tracking. Our method currently works well for separate cuts of meat and the cuts of meat touching each other. The work in progress with cuts of meat overlapped or stacked in different orders. So this is a hard problem to solve when multiple meats present, overlapped, stacked each other. So our I also talk about our technology pathway. This is a very exciting research and with lots of challenges. Any questions?
Thanks to Dong. We don't have any questions online, but I've got one. I don't know if we've got anyone from processing facility industry online, but what would need to happen in an abattoir if, these technologies were going to be deployed? So, how much technology would there need to be added to an abattoir setting?
Okay. I told this in two aspects. One aspect is, if this works, then eventually works, and we need to install 3D sensing, which is suitable for the environment. We can't use obviously those HSE restricted, such as laser or something like that. So we need to install the high precision, high resolution 3D imaging sensor. Also, some of the process may be need to be regulated. For example, if a piece of meat being thrown from nowhere, we can say those type of behavior need to be regularized. That's one aspect. Another is there are some new technology which make sure it's recognized. There are some new technologies like robotic butchers. So they are they are used in abattoir to automatically process those meat. Even we still need to track those meat, but the behavior is more recognized regarding how those piece of meat being cut from carcass, then being thrown on the table, then being moved to conveyor belt.
Thanks to Dong. We'll just wait a few seconds and see if anyone else has got a question or comment to post. Maybe I'll give you an opportunity, Dong. We've got 1 minute left. Is there anything that you would have liked to spend a bit more time on in your talk that you'd like to cover now?
Yes, what I have to say is this is a challenging problem, and so far there's no solution in the world regarding how to solve this. And it's a challenge. It's challenging, but it's very exciting research with what's new sensors and also new algorithm. And if this eventually works, it will be lots of value for the meat export market, because people will know its origin, and our export will be more competitive.